Hello, 7th grade. We are in Unit 2. You did the reading last night, so some of this is going to be repetitive. However, these are the really important things, so I'd like you to pay attention. All right, here we go. Talking about motion today and the basics. This is going to lay the foundation for everything else we're going to do from now until December. You really need to get the ideas of velocity and acceleration down to velocity today. So here we go. First big idea, scalar and vector quantities. What are they? What's the difference between them? Well, we take measurements, right? Okay. Measurements describe what we see in the world, especially in science. We want standardized measurements. Well, measurements come in two categories. You've got scalar quantities and vector quantities. Right? Now, you think of scalar like a scale. It weighs something. It gives you the amount only. The book uses the word magnitude. Right? So it gives me a number. There we are. A number, but you don't have a frame of reference. Okay? There's no arrows, no positive or negative signs. So a scalar quantity is just a number. And some measurements are scalar. Distance, speed, time, mass, temperature, pressure. They don't have any direction to them. Okay? Is that bad? No. It's just that's the way they are. However, when we start talking about motion, and that's what we're laying the foundation for, is the study of motion, we want to know not only a magnitude or an amount, but we also want to know in what direction we're moving. All right? It provides a frame of reference. This frame of reference picks a spot, and we call that the origin. When I move, I'm moving relative from that origin. If I move in one direction, it's positive. If I move in the other direction, it's negative. Okay? So like in math, we've got an x-axis and a y-axis. Okay? These vector quantities tell me where I am on a grid relative to that origin. And this is really helpful for solving problems because with vectors, I can add them and subtract them just like any other number in algebra or geometry or calculus. Okay? So it's really helpful in solving problems. Our vector quantities that we want to use when we talk about motion are displacement, velocity, acceleration, force, weight, and momentum, a moment. Okay, talk about that later. All right, scalar versus vector. Scalar numbers look like this. This would be distance, a distance of 6 meters. Doesn't matter from where to where I'm measuring. Point A to point B. A to B is 6 meters. B to A is 6 meters. However, a 6 with an arrow over it, that means it's a vector quantity. This is displacement. Check it out for the next slide. It means I have gone from A to B, 6 meters. Or I've gone from B to A. The arrow makes a difference. Okay? Shows that we have a vector quantity. All right. So I just used that word displacement. What the heck is displacement? All right. Displacement is like distance, but it's the vector version of it. It gives me not only magnitude, but it gives me direction. Right? Distance is the length between points. It's also a distance you travel. Okay? Distance follows the path. All right? So I can go from the house to the lake a number of different ways. However, what do I really care about? I care about how far away it is, and when I get there, how my placement has changed, how I have been displaced. Okay? So I'm changing my place, and I start here and I end there. Displacement is about the starting and the ending points. Right? It's a position relative to the origin. Right? It's a vector quantity, so it's going to have direction included with the number. The positive or negative sign is going to tell me which direction relative to some axis or frame of reference. Gives me more information. Now, depending on the book, depending on the teacher, depending on the country that they grew up in, displacement is usually abbreviated either S, for the Latin spatium, or X, which is the unknown distance. Okay? D is for distance, So they can't use D because they both start with a D. So it's either abbreviated S, like it is here, or sometimes X, change in position. Cool? All right. So, velocity. Velocity is the vector version of speed. Last year we talked about speed a little bit. Speed is change in position over time. Right? So if I want to know my velocity, I need not only that distance, but the direction. All right? If I can tell how far I've gone relative to some other point, then I have displacement. I divide displacement by time. There it is. Displacement by time. I get my velocity. Very similar to speed, but it's also different in important ways. We're going to see that in our labs and in our problems. Right? That direction component really helps us. Right? And it's a rate. All right? It's changing. Displacement changes over time. Position changes over time. Now, neat things happen when you graph displacement versus time. There's my mouse. It keeps disappearing. There it is. So if I put time on the horizontal axis, and it's always, well, 99% of the time is going to be on our x-axis when we're talking about motion. And my displacement goes on the y, all right? This is my dependent variable. My position depends on the time, okay? What happens is the slope of the line that's formed, slope of this position versus time graph equals your velocity. Remember, slope is change in y divided by change in x. My vertical change divided by my horizontal change. And so if I take my distance, or I'm sorry, my displacement, and divide it by my time, that's the slope, and the slope of this line is my velocity. All right? If you don't get it, that's okay. I want you to hear it many, many times. We're going to do it in the lab. All right? So here's another graph. When I look at that graph, the shape of the line tells me a lot. Look right here. If my displacement isn't changing for 2 seconds, I'm not changing my place. What does that mean? It means right here, I'm not moving. A horizontal line means no change in position. I'm standing still. My speed is 0. My velocity is 0. When I see a curved line, okay, this means that I am accelerating. I'm going faster and faster and faster. I'm covering more distance each second than I was the second before. So my speed is increasing. When I have a curved line, that means I'm either speeding up or slowing down. Right? If I have a straight line, this means I have constant velocity, or constant speed. I'm moving. You can see my position is changing over time, but it's changing at the same rate. Therefore, my velocity is constant. Okay? This is the introductory video. We're going to do this, but I want you to start to understand this. All right? So ask questions in class. Quick review. You want to leave this video knowing the difference between scalar and vector, the difference between distance and displacement, and you want to understand speed and velocity and exactly how we can calculate velocity from the graph. Right? We're going to practice. The reading, chapter 11, sections 1 and 2. Write down your questions, write down your text, write down what you heard. Draw a picture. See you in class.